Adam Bear with Bear Process Safety. This is episode 2 of Breaking Down the Basics. We're taking a look at OSHA PSM regs. This is still in PSI, but now we're talking about information that's pertinent to the technology of the process. We're starting out here with the process chemistry, which includes material and energy balances, and a simplified block flow diagram or a process flow diagram. So number one thing you want to be looking at is process chemistry. This is the lifeblood of what's happening in the process. It can be great for someone who's not quite as familiar with the process. That could be someone in your corporate situation, or maybe you've got a third-party vendor coming in. Also for new employees, this can be great pertinent information. Things you want to look for there, or is it exothermic, is it endothermic reactions? What are your main products that you want? What byproducts do you expect? Is there potential for runaway reactions? That's going to be very important from a safety standpoint. You need to know what temperatures you need to avoid, what pressures you need to avoid, those sort of things. All that information should be in the process chemistry. It's all normal information that we have. We just need to make it readily available and have it in a form that is accessible to everybody, easy to understand. We'll show you an example here in a second of a block flow diagram. It seems like something super basic because it is, but it can be a valuable tool, especially for those new employees or people reviewing your process for the first time, to be able to look at something as simple as blocks and arrows, but showing how the process goes from unit to unit or area to area. That is just key piece, and really, to be honest, it's a document that can be created relatively easily. So lastly, we've got our process flow diagrams. We'll show an example of that and talk in more detail. With your process flow diagrams, the important point is to make sure that all of the flow stream data is there, including operating pressures, temperatures, sometimes even density. Make sure you don't leave any of those chemicals out. And then you'll have a corresponding stream for each piece of equipment, each line within the process. This is not where we're talking about our instrumentation or really great detail. That's our isometrics or our P&IDs. But we do want to get a semblance of what major equipment is in the process. Here's an example of just a basic block flow diagram. I know it looks super simplified, but this can actually give a lot of information to new employees or employees who maybe only deal with one section of the process, to kind of explain to them where their section fits in or how the whole process happens. And like I said, it's simplified. You've just got, as you can see here, a box at the top. RX reaction takes place. It goes to distillation. Based on distillation, product goes to storage. Waste goes to treatment and to disposal. So this can cover, if you have multiple units that tie into one another, that can be covered that way. You can get super detailed within your process. You could be very high level if you just want to do a block flow that shows, hey, this process goes in the next process. Additionally, with this, what I would do, which helps employees a lot, is give them kind of a narrative to explain what they're looking at and what the flow of these are. What are some important things about these steps here. The second example we have here is then going to be a little more detail. It's going to be your process flow diagram, and I just kind of drew a little column here that's got some stream numbers 1, 2, 3, and 4. So this is kind of the detail that then you're going to want with your process flow diagrams. It's not instrumentation, but it's going to be the main equipment, basic equipment that you're looking at to get a good semblance of what's going on with streams, temperatures, pressures. You can see to the right of it here is a little block that's kind of got, hey, we've got an acetylene process with some water, some nitrogen. It's showing the stream compositions, showing the temperature that we're expecting, operating temperature that we're expecting, operating pressure that we're expecting. Sometimes in these, it's good to put what's the max you're expecting, or if you have multiple modes within the same equipment, you may want to do a different column for modes. You may want to do a whole nother process flow diagram for a different mode that you have. Let's say you're in a regeneration mode for processes that regen catalysts, or if you're running in a single pass-through mode or 2 concurrent lines running, if that changes the streams or changes any of your conditions The key factor that you want to have there is you don't want to miss a mode. You don't want to miss a chemical that's being run. This is going to be very important when you're assessing hazards. It's also very important for your operations team. I know it's theoretical numbers, but it gives a baseline of what we're kind of expecting. And that can be used. We're going to talk about this later in PSI, consequences of deviation. Those kind of flows and those kind of expectations can be used when building that information as well. So that's just two examples. Drill on the board here, just to be able to kind of show you what we're talking about. You could be more detailed, you could be a little bit less detailed, but that's kind of what we're looking at.